You've seen the import keyword used a couple of times in Math 11 already, and I'm finally going to explain what it does. So the idea is that other people can package up their code in what's called a module, and then you can use it in your Python code by using the import keyword. So let's see an example of doing that. In this video, we're going to go through a couple of important modules that are included with CoCalc and with any standard Python distribution, which are the math module and the random module. So starting off with math, which contains a bunch of mathematical functions, so trigonometric functions, inverse trigonometric functions, logarithms of various kinds, and some constants as well. If you want to know the full list, then the version of these slides, which I'm going to put on Moodle, either as a PDF or as a notebook, will have a clickable link right here, which will take you to the documentation for math. Anyway, if you want to use the math module, what you need to do is type import math, and that just has to be somewhere in your DoPython notebook. You only need to do it once, and then you can use all the functions from math anywhere in the notebook. So let's run this so that we have math imported. What we can now do is access mathematical functions from the math library using the notation math dot and then a function name or a constant name. So math.e, when I run this, will give me the number e, so 2.71828, etc. If we want to have some trigonometric functions, we can do math.sine of 1, for example, sine 1. If we want pi, so math.pi over 2, that should be 1. Okay, you can also do things like math.cosine of math.pi over 2, which will be very close to 0. So of course, math.pi is not exactly pi because it's just a finite decimal representation of pi. So math.cosine of pi over 2 won't be exactly 0, but it's something extremely close to 0. You can see here e to the minus 17 means multiply by 10 to the minus 17. Okay, one more example. Let's see a logarithm. So math.log means logarithm to the base e, so natural logarithm. So just to show that that's correct, if we do math.log of math.e, that's 1. So math.log really is the natural log. And if you want the log to the base 10, then you could do math.log 10 of, for example, this, and that'll give you 5. So this really is the logarithm to the base 10. Okay, so any mathematical functions which you can find on a scientific calculator, you'll probably find them in the math module. And if you want to see the exact full list, click the link which is on the Moodle version of these slides. So there are other ways to use import. You can import a module and give it a different name. For example, if you were importing a module which had quite a long name, you might want to give it a shorter name. You can do that by typing import something as something else. And that will help you to change the name of the thing you're importing. So if you don't want to type math all the time, then you can do import math as m, and then you'll be able to use m.cos instead of math.cos. So here, if we do m.cos of 0 after we've done import math as m, that'll work and that'll give us 1. Or if we do atan, so that's the inverse tangent function. Let's just see if this works. Let's put a few 9s in there, see what happens. Yeah, we got just about pi over 2, so that looks as if that's working as well. So atan is arctan, or the inverse tangent function. All right, there are other ways to use import. So if you want to import one or more functions or objects from a module and use them without any dots, you can do that with from and then the module name and then import and the things you want to import. So for example, if we do from math import atan and sine, then we can use sine and atan without using any dots at all. So we can do this, for example, and again that'll be about pi over 2 because sine 0 is 0 and arctan tends to pi over 2 as its input tends to infinity. So yeah, that's another thing to mention actually. All of the trigonometric functions and inverse trigonometric functions in math all use radians as their inputs. So that's why I'm getting pi over 2 there as my output when I give arctan a very large number. Now you can also import every single function from a module so that they can be used without the dot, and you do that with from math, for example, import star, import asterisk. So in this code cell at the bottom there, I've got from math import star, and if I run that, then I can use absolutely any function from math without using any dot notation at all. So for example, radians is a function in the math module which converts degrees to radians, and radians 180 then will give me pi, because that's how many radians there are in 180 degrees. So there is a reason to be careful with using from something import star, which is that math, for example, contains lots and lots and lots and lots of functions. And if you were writing Python code and you'd got a particular function with some name which happened to also exist in math, then when you do from math import star, your function will get overwritten with the same name function from math. So it's not always a good idea to use from math import star. If you know that you just need a couple of functions, then you could just import them on their own, like we did in the code cell at the top there, or to be completely safe, just import math and then use math.whatever to access your math functions. Okay, so that's this math module. The other one I want to talk about is the random module, which has functions which generate and use pseudo-random numbers. I'm going to describe a few of the most useful ones, and again, I've put a link there on this slide to the online documentation where you can find the full details of everything that's in the random module. So we'll begin with an import random so that we can use these random functions, and one of the most common ones is random.randint. So random.randint a, b produces a random number between a and b, and it includes a and it includes b as well. So this is not like the Python range function. Unfortunately, it's just a bit inconsistent in this. But random.randint 15 could produce any number between 1, 2, 3, 4, and 5. So let's run it just a few times, and you can see I often get a different number, and you can see I really did get a 5 there. So it is possible to get 5 in random.randint 15. All right, you can also generate random floats, random decimal numbers. So if you want a uniformly distributed random number between 1 and 3, so let's just correct that comment there, then you can do random uniform 1, 3. Or if you want a random uniform random number between 0 and 1, then random uniform 0, 1 would do this. Again, let's just update the comment there so that it's correct. All right. So yeah, this can give you random decimal numbers, uniformly distributed, and a certain range. There are many more functions in random. For example, there is a function for taking a random sample. So if you want a sample of a certain number of elements from a particular list, sampled without replacement, so that means you're not allowed to get the same thing twice, then you can use random.sample. So if you call random.sample with the argument being first a list and then a number, then it will try and pick, for example, 2 things here from that list at random. Without replacement means that it won't get the same thing twice. So the number that you use must be at most the size of the list. So here we picked 2 things at random. We got an E and a B. If I run it again, I'll get 2 different things, an A and a B this time. Run it again, a B and a D, an A and a B, an E and a D, an E and a B. Right, so you can see what's going on there. And most importantly, this is sampling without replacement. You can't get the same thing twice. Random shuffle, on the other hand, will rearrange a list. So if you call random shuffle on a list A, then what happens is A will change, and it will change by being rearranged at random. So, of course, there's a small probability it remains the same, but any permutation of A is possible, and each one has equal probability. So here I rearranged A, and I got 3, 2, 1. Do it again, we get 3, 1, 2. Do it again, 3, 2, 1. Okay, a different rearrangement each time. Okay, so that's what random shuffle can do. If you want to rearrange a sequence at random, then that will do it. But it's important to remember that it does modify the original sequence. So if you start off with a list A, then random.shuffle of A changes A. Finally, you can create your own Python modules. So if you write Python code and you save it in a file mycode.py, so you can't do this with a Jupyter notebook, but if you're using Python in a text editor of some kind, then you can do that. And if you place it somewhere where the Python interpreter can find it, then using import mycode will make the code from mycode.py available. This is not something we're going to do in Math 0011, so you can ignore it. But if you want to do that, again, there's a clickable link in the online version of these slides, which will explain what you need to do.